have to hold on to things. Okay, I'm Evgeny, the Guru CTO and founder, and that's going to be like a technical architecture kind of talk about how we deliver in Web2 user experience for our Web3 application. So Index Guru, we index in 70 dexes across multiple chains and like enormous amount of trading pairs, tokens, whatever we have. And obviously, it's kind of impossible to do it solely on Web3 because, like, as everyone knows, like, the node itself, under the hood, it's a key value storage, and you're very limited to what you can do with it, how you can access the data, how you can select and search the data. Of course, it's decentralized, but it's slow to write and kind of slow to read. It's very costly to do both things. So to power up something like that, you need some caching layer in between Web2 and Web3, and that's the only way everyone proceeding right now. So solutions-wise, we need indexing, obviously. So to get Web3 into Web2, then to get our Web2, Web3 application working on top of it. Let's say Azure Scan, right? I just stole that picture from some explainer from YouTube, but basically what they do, they index in blockchain into a centralized DB, and then all of us can explore all those things in Azure Scan. That's how it works. Or the graph. The graph is cool. It's kind of the same approach, like indexing stuff, but then the data layer itself is decentralized, and you have like a pretty complicated way of contributing to it, as well as it's paid to consumers and creators. So the graph is really cool, but for applications like ours, it's not there yet in case of like a DB tooling, analytics toolings around it. So traditional DB is offering much more tooling to analyze the data. So you can execute actual analytics jobs on your nodes and so on and so forth. It doesn't exist in the graph yet. And here is how we're doing it. And that's pretty much what DexGuru uses to get all that information. So we actually currently using 3 different DBs and a bunch of indexation workers for every network we support, as well as we parse in hell of a ton of different events from different dexes and put them in all of those DBs simultaneously. So we have Redis, which is like a cache for our real-time data. So users, whenever they hit on our website, can see those real-time things really real-time. Then we have Elasticsearch, where we have like search, select, and aggregation possibilities, as well as we executing some data analytics scripting on top of it. And that code is actually executed on Elasticsearch nodes, so you kind of utilizing sharded computer power there. That's when you're indexing millions of transactions and trying to calculate prices of them, like trending, categorize traders, and figure out if whales are selling or buying right now. That's a crucial thing to do. Also, we're using ClickHouse, and ClickHouse, it's mostly for the thing called materialized views in ClickHouse. That's like an pre-calculated view of your data based on your ingestions. So ClickHouse is used on our website to calculate balances of every trader, so you can see like when he was selling or buying, and what's the top token holders, and so on and so forth. So we have like a zoo of different databases in here, and we indexing in all of them right now because all of them providing different tooling, and whenever we are indexing different chains, we are actually hitting different performance issues. For example, indexing Ethereum is not the same as indexing BSC. Much more transactions, blocks coming much faster, so you're figuring out next approach to it. Maybe you're switching DB and so on and so forth. So that's where you are at. So what's actual pros and cons? Of course, I already talked about it. It's like traditional DB's been there like for many years, and they're really good at things they're already good at. You can get as much speed as you want. You have in-memory DBs, you have sharded DBs. You can actually parallelize your queries across multiple nodes if you have replicas. So like squeezing up the speed is actually what makes traditional DB solutions much faster than basically grabbing it against Web3, even if we could request the data from Web3. So there is all kinds of database as a service solutions from clouds. So you can actually, instead of managing it yourself, you're basically outsourcing it to AWS or something, and then basically just getting everything out of it. The next thing is about like business scalability. Actually, if you grow in your product, you need to scale up your team really fast. And whenever you're trying to find Web3 developers or anything related to smart contract or anything like it, it's really hard to find people on that market, as well as prices are really high. But when you're trying to solve this problem, you figure out, okay, I have indexation, I have whole Web2 tooling, so I can actually hire Web2 developers for everything what's not related to Web3. So you can scale up your teams, which solely focus on organizing backend, organizing data analytics, and maybe doing some new APIs and so on and so forth with Web2 developers. And all those toolings which is available, like executing actual queries and aggregations on database nodes themselves, really complicated stuff sometimes. Like you have scripts running on the nodes, calculating some averages, means to figuring out if data is biased and so on and so forth. Of course, cons of it is you centralizing everything, right? And what we're actually going to do with it, because we all know that we want to go in the direction of decentralization instead of centralization. So how are we going to decentralize solutions which are needed for analytics? And like in blockchain, everyone needs to understand that we have like tons of data, like thousands of transactions happening every block and every minute, and even for traditional kind of indexation and database problematics, it's a huge piles of data. But if we're trying to do decentralization at the same time, it's even more challenging and so on and so forth. So what we do to decentralize things and how we are planning to approach it. So currently, we are like a year in development, and during that year, we try different approaches, and we see how to build some of the analytics on, let's say, on Redis. Redis is key value storage as well, and whenever we try things on Redis, obviously, if those things work on Redis, we can migrate them to something like layer 2 plugin for the nodes, which would work with LevelDB, same way it's working with Redis, and then we have something like plugin for some particular feature, some particular analytic feature, or maybe set of them, and then we can actually decentralize that plugin which we're hooking up to every node. That's pretty much how the graph approaches it, but maybe we would need some more customization that the graph provides. And that actually comes to a third thing we have in mind, that we need something like L2, but for data layer. So nodes would be working themselves as they are right now, but we would have like plugins which are working directly with nodes DB, like without any Web3 API in the middle, and organizing themselves into layer 2, but for the data, with additional features on how we can So let's say it would be layer 2 for DeFi data or something like that. So you would have actual swaps, burns, means from every DEX possible already there, ready for querying in different kind of ways and so on and so forth. So my talk was labeled as workshop. I'm not sure how many developers I have in here. Any Python developers? Oh, really? Okay, so to get to the point, to actual developers problem here. So this is like the cycle we do for every block. So to actually get all the transactions from all the transfers, as you see them in Azure Scan, let's say, for some transaction from the block, those are all operations you need to do against EVM node. So you need to get last block numbers and get all transaction indexes from the blocks and request all transactions by their indexes, so it's like a loop there. Then request recepts, because you parse in recepts to get transfers. And then basically in recepts, you're looking for transfers event, and that's how you parse in the thing. So if you're looking on something like, this is a transaction of Azure Scan, and you see here, Azure Scan already did a nice job and actually parsed transfers in here, and you see tokens and everything. So how, okay, it's too small, sorry. How the hell you would get it parsed out of your pure Web3 node? So from Web3 nodes, you get in something like this, and it's like unparsed recept logs. And because we have so a little amount of developers here, we can go through the code actually, but probably it's not useful. But you guys can go and check actual GitHub in here, and just cloning it. You basically have that portion sorted out, so you can actually start indexing transfers into a DB of your choice and start analyzing them. And those are ERC20 transfers. And by swapping ABIs there, you can actually start indexing NFT transfers if you want. So that's the idea. And that's why we need to have indexation, because this is a way to get transactions for one block. And we're converting it in DB, we're converting it to the view where it's easily searchable or requestable by any key we want to request it by. So that's the complexity. And in Index Guru, we have sets of those workers which are actually like working with dozens of nodes on different chains, and that's how we get in like real-time data. And in summary, it's like 1,500 Docker containers right now, which are running that kind of code all the time. So yeah, that's the question section. Any questions on?
So this work was something like with what Celeste is doing, kind of trying to do.
I'm sorry. So like a data lake?
No, it's a data layer. They're just publishing all the transactions directly at Bytes. Is that something you would look to analyze?
I hadn't checked them, but what we do. So all data we index in, we actually have as an API available, like as a public API. So you actually, after we already indexed that, normalized it, you can use our public API to go through transactions which are happening on all DEXs across different chains and see like a pricing feed which we calculated for you already. So we providing some access to our data already. It's not like to all the data, and we planning on extending our API, so you will have like more access to raw data, and maybe just kind of giving it to the world as a database interface makes sense in some way, you know, like, yeah, that's definitely what we may say. Yeah. Any other questions? Cool. So here is my Telegram, Twitter, DexGuru. We're hiring as everyone here, if anyone interested. We're sitting on a pile of data and looking for someone to start analyzing it. We're doing some categorization right now, but looking for more things. Okay, that's it then. Thank you, Will.